Good morning and welcome to the latest edition of Civica's Perspectives, looking at machine learning and data and AI, all part of a spectrum. I'm your host, Helen Olsen-Bedford from UK Authority. Usual reminder, housekeeping, before we start, questions for the panel, please put them in the Q&A. We can have those up in the various Q&A sessions that we've got planned during the session this morning. There's a couple of polls, please join in. We're really keen to hear what you think as well. Use chat, say hello, and any other comments and questions. So now that's out of the way, cracking the machine learning matrix. The data we've got at our fingertips is growing exponentially, and add this with increasing computing power, ever easier tools to work with, etc. And we've got real opportunity here. It's all part of a spectrum, data, machine learning, AI, and it forms a massive opportunity for the public sector, but it's not without its pitfalls. So today we've brought a collection of people and speakers and panelists, etc., to explore the whole issue. So first of all, we're going to kind of enter the matrix, and we're going to have Timandra Harkness of Big Data, author fame, and also Radio 4, Giuseppe Sollazzo, who is Deputy Director, Head of AI at the Skunkworks for NHSX. And then we're going to move into a section where we're going to have some quick fire innovation pitches from some SMEs in this area that are using machine learning AI for innovation and to see what they can bring. Then we're going to bring it all back together into a panel where we're going to have Eamon O'Neill from the University of Bath, Patrick Dawson from Paradigm Housing, Harold de Cleef from Civica, and Dan Sandu from Sparks Learning, where we're going to actually bring it back to what does this mean for us today. So I'm going to stop sharing there. And I'm going to ask Timandra, if you can start getting ready, that would be fantastic. And while she's doing that, I'm just going to put the first poll up. And it's about data, because like I said, it's all part of a matrix that starts really and ends with data. So on the data front, how good is your organisation's data? How good is it? It's all there, it's all accurate, it's all up to date, everything's perfect. Still looking for it, still trying to find an audit of where it all is. Timandra, can you get your slide on? And perfect, we can see you. Can't say fairness without saying AI. That's a great title, Timandra.
I would say great to see you. Great to know in my heart that you're all here with us in this new virtual world. I thought of this title because I was actually thinking about what AI and machine learning can do for fairness, and it struck me as quite a nice little joke that actually AI is right there in the middle of fairness, whereas if you look at it the wrong way around, it's there in bias. So I wanted to take that as my kind of theme. So you'll have to indulge me. I have a weakness for puns, and I love the pun that you can say AI, you can say Al for Alan Turing, and here he is in his prime. And I like to start with him because he wrote this incredibly prescient essay in 1950 about the idea that one day we would have machines that learn the way that a human can learn. And he said some really sweet things. I mean, obviously he was a genius of computer science, but some of the way that he thought this through is really, really endearing. So he thinks through in great detail that he will have this machine that learns like a human. And then he's thinking, well, okay, but you won't be able to teach it exactly as you would a normal child because it would have legs, so you couldn't send it out to fill the coal scuttle. And obviously sometimes, if there's any of you under 30, you're probably looking a bit confused now. A coal scuttle is a metal bucket. You fill it with coal because in 1950, when Alan Turing was writing, everything in his house would have run on coal, heating, not lighting, obviously, but heating, cooking, hot water, everything. And I just love the idea that he could foresee machines that learn like humans, but he couldn't foresee central heating. And then he goes on even more endearingly to think, okay, well, engineers could solve this. It could have legs, it could have eyes, but you couldn't send it to school because the other children would make fun of it. So again, we've got Alan Turing, who, as we know, had a very troubled personal life, already worrying about his little robot child going to school and being bullied for being different. So when I talk about robots and AI, I'm on a bit of a one-woman mission to get rid of that mental picture of it's either the Terminator robot with the red eyes or that annoying white plastic robot that leans over your computer and robo-splains. So I'm trying to replace that in your imagination with little Al, who is Alan Turing's robot child and half robot. Now, Alan Turing didn't have children, obviously, and this is really clear when he goes on to describe a basic computer algorithm with the analogy of a child. See what you think of this. So he goes, okay, so you've got mother who's got a child called Tommy. Mother asks Tommy to call at the cobbler's every morning on his way to school to see if her shoes are done. She can ask him every morning. And although I'm too lazy to have children, I understand this is a very plausible scenario. But Alan Turing goes on. Alternatively, she can stick up a notice in the hall, which he'll see when he leaves for school, and which tells him to call for the school shoes. And also when he comes back, if he has the shoes with him, to destroy the notice. And well, I don't know if any of you have ever met a child, but I don't think that would happen. But for a computer algorithm, it's an absolutely brilliant analogy. So a basic computer algorithm of the kind he's describing here it's like a flowchart for a machine. And I assume you've seen a flowchart before. So if yes, then you will know what I mean. And if no, you have now, because this is a flowchart. So if we go back and use his story of the mother and little Tommy and the cobbler, and we write it as a very basic flowchart or computer algorithm, it works perfectly. Step 1, go to the cobbler's. Step 2, ask if mother's shoes are ready. If the answer is no, go back to step 1, although I probably should put in here to wait a day, otherwise the cobbler just gets really annoyed as the child goes in and out on a perpetual loop. Any of you that write computer code, this may look familiar. And you keep doing this until the answer is yes, at which point you go home and take the notice down. But of course, when he's talking about a machine that learns like a child, he is thinking of something way beyond that. He's thinking of a machine that does not need to be given every stage of the instructions. So you would say to little Tommy, can you get my shoes from the cobblers when they're ready? And little Tommy would work out, if he was a machine learning algorithm, would work out the best way to do this and would do it. And you wouldn't have to worry about the in-between steps. And this is, in fact, where we are getting to now. When we talk about machines that learn like children, there is a literal robot called the iCub, which is shaped like a child and designed to learn like a child. So, for example, if you want to teach it that you are handing it a thing called a red ball, you hand it a red ball and you say red ball, and you do this repeatedly. It's a red ball. It's a red ball. Seems to have got a bit annoyed with the whole red ball thing here until it's grasped that it's a red ball. And this works surprisingly well. They actually even do parallel experiments with the iCub and real toddlers, and they find that they can let it learn in a similar way to how humans learn. I mean, I don't want to get into the philosophical thing about whether robots can think, but in terms of learning, finding patterns, matching things up, doing tasks, they are really astonishingly sophisticated and successful. There was a machine called IBM Watson, made by IBM, obviously, which won a game show in America called Jeopardy. And it was quite a tricky game show. And to do that, they set it loose on the internet to gather information that had been written in normal English for humans. Probably in other languages, actually, when I think about it. It's called natural language processing. And it absorbed information. And it absorbed meta information about how reliable that information was. And it came back and it won this American game show called Jeopardy, which is very tricky because they word the questions as answers. And so the answers are questions. And if you can see the details of this slide, you'll see that the answer they've given is, who is Bram Stoker? So the question would have been something like, I wrote Dracula. You can also see one of the humans who was in the process of losing to Watson has written, I, for one, welcome our new computer overlords. So are they our overlords, or are we still in charge? I think this is an important question. So I'm not going to go into detail into use cases, because I think you'll get a lot of chances to hear that. But for example, this is just a very recent one. This is in India. There's an app to predict crowd levels in public places to keep the public transport and even foot transport moving in India. There's a lot of uses of these kinds of things because machine learning is good at finding patterns in enormous quantities of data, which we can now get because it's automatically gathered whenever you use a smart card, or even if you walk around with a smartphone, it's sending a signal that you're there. So a machine learning algorithm that can absorb that amount of data and find patterns is really good at big picture stuff like how people are moving around. You can just imagine, I mean, MIT are doing some projects with the Transport for London on exactly this kind of thing, predicting supply and demand, flow of people. You can imagine how much difference that would make to the efficiency of a transport system, but also to the efficiency of a whole city. This is one of my favorite visual aids. This is a tweet about taxi demand in New York City, because the New York City Taxi and Limousine Commission collect all the data from all the taxi meters. So you get incredibly detailed data, and then it's been put into the public domain, anonymized, obviously, by a researcher called Chris Huang, who saw this tweet and went, oh, well, they're a public office, so I can put in a freedom of information request. And they said, this is a ridiculous amount of data. You'd have to come in here with a huge hard drive. And he said, I'll do that. I'm a data scientist. So if you're interested in that kind of thing, it is available in the public domain, and it's all sorts of interesting things to be found there. But you can see, again, very detailed pattern of shifts in supply and demand. You imagine how useful that would be for transport planning. So, so a couple of caveats. This is data from an app called Strava, and some of you may use it. It's very popular with cyclists and runners in particular. You can follow your route, you can follow your progress, you can compete with your friends, you can see where you've gone and whether you're faster than before. And because Strava have so many people using it, it's a free app, they have, again, a lot of aggregated anonymous data about where people go. So this is a heat map of New York City of where people cycle. So some city planners thought, well, this is a marvelous thing. We have all this information about where people cycle. So when we're thinking about where to put new cycle routes, we can use this information. That's obviously where we need to put the new cycle lanes. Okay, I mean, it's a perfectly reasonable thing to think, but I'm now going to show you another picture, which you may have seen before. It's quite a well-known image. This is an image, an aggregated image of the aircraft that came back from bombing raids in World War II. And the red dots show where it was hit by enemy fire. And the question being posed was, we can put a bit of armor on these planes. We can't armor them everywhere, but we could put it in one or two places. Where should we put the armor? And so the question was put, do you armor the ends of the wings? That gets a lot of hits. Do you armor the middle? Because that also gets a lot of hits. Do you armor the tail? That's also had a lot of hits. And the answer came back, no, none of those places, because the planes that got hit in those places came back. The planes that didn't come back were the ones that got hit at the front, the engines, and the middle of the tail. So that's where we need to put the armor, because we need to think about the data we don't have, the planes that didn't come back. And just to pop back to the cycle route, if you think about those are the places where people are already cycling. Those are the places also where the really confident people in Lycra are cycling, and not the wimps like me who frankly refuse to cycle on the roads because it's too dangerous. So you always need to think about what's missing from the data, and therefore what else do you need to put into your machine learning algorithm so that it can learn from what's happening now, from what information you have, and then think about where it is you want to get to. And this brings us on to, oh, sorry, I'm already overrunning. I shall motor through. This brings us on to the question I started with about fairness. So here's some questions from a question that's been in wide use in the justice system in America. And luckily you're not here, so I can't get you to put your hands up because this is always quite interesting. How often did you have conflicts with teachers at school? Never, sometimes, often. I'm a sometimes, just to declare. How much do you agree with this statement? I have gotten involved in things I later wished I could have gotten out of. And if you're sitting there thinking, oh dear, that does sound true, I have to say, I think if you're over 18 and you don't answer, agree to this, then you haven't really lived enough. And finally, many people get into trouble or use drugs because society's given them no education, jobs, or future. How much do you agree with that? Now, interesting little psychological thing, you might think, interesting sociological question, but it actually comes from a questionnaire called Compass, which is used to give people risk scores for reoffending in America. Now, this was really, really controversial. It was quite wide use in America. And the motivation was they knew they were locking too many people up, and they wanted to lock fewer people up, and they wanted to find the people who probably wouldn't reoffend so they could not put them into the pipeline, send them to jail. And research is happening in the UK as well into trying to find similar programs. And then this article came out in ProPublica. They'd done a deep dive and said, well, this is really biased, this algorithm. Even though you don't ask about race, it turns out that the risk scores that come out between Black defendants and white defendants are really different. So you're just perpetuating racism. You've got an algorithm which you say is going to make things fairer, and it's actually making things more biased. But the company that made the algorithm, and they won't reveal details because it's a proprietary algorithm, came back and said, no, you're wrong, actually. You've got these figures that show that African Americans are much more likely to be wrongly tagged at high risk. But we are going to go through and show you in detail, I will spare you the detail, why you're wrong, because you've actually sorted this data in the wrong way. And they said the problem is, the thing you're not taking into account is that if you divide people very simply into those two populations are not the same. They actually have different rates of reoffending because they have a completely different social situation, social history. You cannot just say, why are these outcomes not the same? Because they are not the same populations. The problem, there is a problem here. There's a problem of inequality. There's a problem of unfairness, but the problem is not in the algorithm. And you could say the problem is in the data, and certainly, as we saw with the Strava example, how you gather the data actually has an effect. But you could also say the problem is in the real world, and what the machine learning algorithm can do is reveal the unfairness and then pose the question back, well, what do you want to do about the unfairness? Because you cannot solve it by tweaking a machine learning algorithm. So in that sense, I think that I think maybe people have are a bit less, as long as we get the right algorithm, it will be completely objective and all unfairness will be ended. But I think the thing that it really can do is reveal to us where the unfairness is. And that throws the question back to us as humans, of course, well, what are we going to do about it? So apologies for overrunning somewhat. I'm going to stop now and hand over to the next speaker.
Timandra, that's great, thank you. And a really interesting question has come in on the chat on that, which we'll pick up later when after Giuseppe has spoken. So Giuseppe Sollazzo, please, if you could come on screen and get your slides ready. I'm just going to share the quick results from the last one. It's not just the data that we've got missing. We don't have a lot of data in the first instance that's in a great set there. We'll pick that one up afterwards in the poll. So over to you. I will see you in a bit.
Brilliant. Well, thanks very much. I have to say that people keep saying that I have the most hipsterish job title in the whole of the UK public sector. But that doesn't make the Timandra an easier act to follow. So I'll do my best. So let me start with saying, just giving you a bit of a coming out. I am an AI skeptic. I don't believe in AI as the magic wand that will bring, let's say, wondrous, miraculous solutions to all kinds of problems. What I do believe is that if we discount the hype on one side and the negative misconceptions on the other, then we can really see AI for what it is, a set of tools that we can use, develop, control, and create an opportunity to deliver our better. To give you a bit of context then, I am the head of AI Skunkworks in the NHS AI lab, and hopefully you will see my next slide. Basically, the lab is currently part of NHSX. It is a large program. It is funding £250 million of work on AI over 5 years. And the Skunkworks is one of the practical arms of the lab. We also do work in the space of AI ethics, AI regulations. We try and link the thinking about AI with the practical work. Now, what is Skunkworks? Well, the name has a certain pedigree. The name Skunkworks comes from Lockheed, a US aircraft manufacturer that in the 1940s created this small, very focused team of engineers to develop novel technologies. They literally walled off this team to build airplanes with new experimental features without being disturbed. Now, we have taken that concept without really walling ourselves off, well, unless you count lockdown in that. And the view is to bring experimentation and innovation to the NHS by means of tools and processes that use artificial intelligence. And if we fast forward a few years, how did the Skunkworks change the world? Well, the plan is to do that through practical experience. What we want to see is that the organizations we have worked with have become more sound in their approach to AI through building solutions to their problems together with us. And so what does becoming more sound mean? Well, it means having an increased ability to decide whether to build or buy solutions. It means to understand how to create local teams that take care of AI products, if they support AI products. It means also developing the ability to reject products as solution when they don't work, the ability to challenge the assumptions about AI. And for us, the way to realize this vision is to allow colleagues in the NHS to try AI in the context of their everyday life. So by doing this, we can test the potential of AI through proof of concept, but at the same time also upskill the workforce through a knowledge sharing model. So let me give you a few examples of how this worked in practice. Now, let's start with a problem that was presented to us by a team at Gloucestershire hospitals, predicting the length of stay of patients. Now, this may sound like a boring logistic problem, but it's way beyond that. There are hospitals in the country where 30 or 40% of beds are used by patients who stay in for longer than 21 days. I can tell you more. Some of these patients are actually there longer than they need to. There are studies that show that 60% of immobile older patients have absolutely no medical reason that require bed rest. This is in fact harmful to their health. There is clinical research that tells us that 10 days of bed rest can turn into 10 years of muscular aging. So very simply, at one point, the healing process works better at home, where patients are free to move, free to get back to their lives. So you can see the benefit of being able to predict whether a patient is at risk of being in hospital for a long time. And in this project, we deployed machine learning to do just that. And as you can see, once again, this is not a magic user AI. This is all about using an algorithm to generate a prediction, a number, that can be used by doctors and nurses to take better informed decisions, which can then result in better care, because that number can be used to prioritize patients for observation. It can be used to allocate patients to wards with beds that are better equipped for longer term use. It can be used to prepare the patient for their physical rehabilitation. It can be used to arrange family and community care. So how do we do this? And this is where the fireworks happen. So we followed an approach that tested modern neural network architectures on different aspects of this problem. Now, this is where it gets really, really technical. I might have to point you to my data scientists if you need more in-depth explanation. But let's take, for example, the training data. Now, we have this huge data set, almost 1 million admissions and outcomes, which by nature comes with a lot of missing data. Now, in order to complete missing data, we use a modern method based on something called a generative adversarial network, a GAN. Now, this is a bit complex to explain in full, but a GAN is basically a neural network architecture based on formed by two separate neural networks. On one side, you have a generator of data that learns to generate plausible data, and on the other, you have a discriminator, which learns to distinguish the generator's fake data from the real training data. Basically, what you do, you train the generator to create data that tricks the discriminator into thinking it is real. Now, if you twist this idea a bit around, this is fundamentally a way to generate synthetic data, complete data in the database that somewhat fits in the real data. Now, if we get to the actual prediction, in order to generate the prediction of stay, we actually took inspiration from the discriminator, which is called a convolutional neural network. Is once again another modern machine learning architecture. Broadly speaking, the process generates new data, and that new data, new lines in that database, can be read, interpreted as a prediction. A prediction is none other than generated data that is very close to the real data in terms of length of stay. And we took that prediction, combined it with a risk model that uses a cumulative density function to produce a risk score for each patient's likelihood of becoming a long-term hospital stay. Now, after all this AI fireworks, what we get is basically just a final number, a risk score for the patient to become a long stay from 1 to 5. And as we said, this number can be actioned. And our colleagues in Gloucestershire are exploring how to put this idea into production, into better care, happier patients. And this also gives us more efficient hospitals, less stretch stuff. So, a successful deployment of this idea could save the patients months of hospital stays overall, and the hospital millions of pounds that could be used on better care rather than longer care. Now, talking about new technologies and interesting novel technology, I want to mention this project we just finished that came to us from the radiology team at George Eliot Hospital in Nuneaton. And they came to us with a very interesting problem about aligning CT scans, which definitely pushed the boundaries of what tech we tried. Now, what's the problem here? Now, let's imagine we have a patient with a tumor. They get non-surgical treatment, which could be radiotherapy, chemotherapy, and the radiologist needs to look at the old scans versus the new scans and say, good news, the tumor has shrunk, or not so good news, it hasn't, we need to adjust the treatment. Now, the challenge here is that we're looking at CT scans, which are bidimensional slices of a three-dimensional lesion. and the radiologist currently needs to use their experience to try and align the different slices they need to look at and understand exactly where to look at. And this takes time. It takes about 30 to 45 minutes. Now, it is a time-consuming process. It is also error-prone because it's really depending on the experience of the radiologist. And it's not even the most interesting part of their job, to be frank. It's not the best use of their time. So the question here was, can this somehow automate it? And the answer is yes. We have a proof of concept that has shown this is possible. Now, for the geeks like me, this gets really interesting, speaking of fireworks, because of the machine learning AI vision algorithms we use. And we use a variety of techniques here. The one I want to mention, which wasn't selected in the end, that is quite interesting to try, was an algorithm called Dino. Now, for those of you who are familiar with internet memes, this is the algorithm developed by Facebook that is able to extract cuts out of videos. Now, we thought it could also extract the contours of tumors from medical imaging. And it was successful up to a point. We had to move on to different techniques. Once again, as you can see, this is not magic. This is using existing tools, existing libraries that can help clinicians do their job better and faster. But none of this replaces the knowledge or the ability of a clinician. And that's, I think, where AI is showing a lot of promise. Now, how do we get to these results? We have a relatively simple proposition for our colleagues in the NHS. Come work with us, we'll help. And we'll do it in different ways according to the degree of digital maturity or the extent of the ideas they come up with. Now, we have a whenever we have a very well-defined or well-scoped problem, we follow the agile approach and develop a proof of concept through 5 or 6 sprints in co-production with a supplier and the organization. It's about bringing multiple skills to the table. We also offer a SWOT capability, basically hands-on practical work to help NHS Trust directly, but we also run deep dives to help organizations understand what AI can do for them, no strings attached. And by doing this, we contribute to addressing a local problem, but we also share that problem and the potential solution more broadly and openly so that others can be inspired. Now, talking about inspiration, there is, for us, a lot of, openness in what we do. In order to properly test AI, we need to be open and transparent. This is part about the, let's say, healthy skepticism that I mentioned at the beginning. Enabling scrutiny and challenge of AI is important at this stage because it can help alleviate, detect, resolve the issues of bias, for example, that AI carries, something that Timandra mentioned in her talk. But openness and transparency for us are positive value. We don't just use them defensively, we fully embrace them. We have a strong open source ethos. We release all these projects as open source on GitHub. And because we believe that sharing code is a fundamental aspect of sharing knowledge and that it adds value to the public money we spend. It also creates opportunities for colleagues in the NHS, for businesses out there, and they can take these ideas and proof of concepts and develop them further. So to summarize, Skunkworks is about testing, learning, sharing. It's about bringing colleagues on, the journey, on the AI journey. And through this journey, we can, I think, prepare the system to engage with AI, having the right knowledge and tools to do so. And with that, thank you very much.
Thank you, Giuseppe. That's fantastic. And actually, Timandra, if you could come on, there's a couple of quick questions, which I'd quite like to pick up, and some of the others we'll pick up in the panel later. Firstly, this issue of trust and fairness, how can we trust the answers? How far can we trust them if there are issues in the first place on fairness? That's it's a big question. We might need to sort of revisit later. Timandra, any thoughts on that?
Yeah, and I think probably Giuseppe will also have thoughts on that. I mean, in a sense, I think this is the biggest question. And one thing I'd like to do is just remind you that my image of machine learning and AI that I'm trying to bring in instead of the Terminator is half robot and half child. And I think that's not a bad way to think about it, because you wouldn't let either a robot or a child perform a task and make decisions unsupervised, but both robots and children are quite good at doing the same thing over and over again without getting bored. So I think trust is a really important thing because it's about a human relationship. You can't just trust a machine learning algorithm. You have to trust the whole setup. You have to trust the people that programmed it, the institution that's running it, the data set that they're using, because of course machine learning relies completely on having a lot of data available. And that's very much about having a two-way relationship of trust with the humans involved. Do you trust the data they are using to be well collected and reliable, but do you also trust the people to have thought, okay, what data don't we have here? What are the, I mean, you know, Giuseppe's example, you look at people in hospital, but you also need to think about who are the people who've not come into hospital that maybe should have, for example. You need to then trust them that the objectives they're giving to the program are the ones that you yourself are happy with. And then you also need to trust them to be, as Giuseppe was saying, reasonably open and transparent, so that other people can come in and say, oh, you know, that's, I don't really understand how you got to that decision. Can you show me? And I think sometimes we think of trust as something you can bank, like Bitcoin, but it's not, you know, it's not a substance. It's a two-way human relationship. And that's why it's really important to not let it break down in the first place. And it also, I think it comes the other way, that if we are not trusted to be like active participants and to have some scrutiny and to make decisions on our own behalf, then it does start to feel a bit like, well, why should we trust you if you don't trust us? I don't think there is a silver bullet to this. I really genuinely think it's a long-term relationship thing, and that it is about being aware of the potential and the limitations, and knowing that you can't really reach the potential unless you're constantly checking and updating and going, oh, well, actually, you know, we didn't think of this, but if we now rethink this and build it into our model, then we can really start getting somewhere and not miss out the things we were missing out. But I would be interested to hear how Giuseppe deals with this on a much more hands-on level.
Giuseppe, over to you on that one.
That's a big question. In medicine, you know, the first thing to say is do no harm. And I think we need to reinforce that message whenever we speak to patients, whenever we engage with new technologies and new problems. I have to say, every time new technologies are introduced in medicine, but in whatever aspect of society, you get that, you know, are we going to be trusting this? And I always think about radiology. Like my brother is a radiographer. My brother, every time he goes into, you know, the X-ray room, he wears a radiation meter, and, you know, can only work up to a certain number of hours. And, you know, but when radiology was first introduced, no one knew about the risks. Now we are in a different time of society where actually we have developed an attitude to manage risk, and therefore we are, you know, happy to test new technologies while also controlling for the risks. And I think if we are open about what we know about the new technology and what we don't know about new technology, we can have that dialogue with the public, with the patients, a bit more openly. And that's why I always say I don't believe the hype, but I also don't believe the negative attitude. What I see is that if we keep the human in that equation, in that, you know, root of, we should never think that AI is a magic wand. AI is a tool to be used by good hands, and those hands will learn how to use AI properly if we do that in a risk control manner.
I just want to check in with our audience. Do you think that you can multiple choice these ones, so you can check yes for any of them. Will citizens be happy? Will professionals be happy with the information? Will they be confident? And will patients be happy with that diagnosis? And while everyone's answering that, actually, Giuseppe, there's a, you know, do you reuse like the long stayers? Are you using the kind of outliers to retrain the AI to iterate? It's a good question that someone's come up with.
At the moment, it's a proof of concept. So, you know, the plan for us was to demonstrate that it could work. And now, you know, the ball is back into Gloucestershire to understand if they want and how they want to put that into operation, which would be, for example, you know, there are multiple ways of doing that. One could be to add that information to the electronic patient record, and, you know, allow clinicians to use that number, as we were saying, to assess the patient. It's an extra piece of information. Once it augments their knowledge, it does not replace it. At the same time, we're also trying to explore the same problem with different NHS trusts. And that tells us something. You know, as Timandra was saying, you know something about the people who are in hospital, not people about, you know, who are outside of the hospital or in other hospitals. And the plan is to try and see how these procedures perform and what do we learn by making them perform in different contexts. Yeah.
And a final question before we need to unfortunately move on to the next section. But and the question is about how, you know, what are the biggest barriers to deploying machine learning in the NHS, technical or people? I would say that's in the public sector, not just the NHS. And what feedback you're getting? Are people worried about your jobs? Any quick thoughts on that? Timandra, will people be worried about their jobs?
I'll give you a quick answer. I think people may be broadly worried about their jobs, and perhaps rightly so, but that's in a context where budgets are squeezed. So, they have reason to think, well, if I can be dispensed with, then maybe I will be dispensed with. But I think there's also an appetite for getting tools that will help people do their jobs better and more efficiently, because people are working with limited resources. So when machine learning and AI can be brought in as a way to help people use those resources better, and for them to do their jobs more efficiently without having to do the repetitive minor tasks, then I think people will welcome it. But it's really all about the context. I think if the context is people going, can we cut our budget and do the same with less, then we all have reason to worry. If the context is we have a limited budget, can we do more with it, then I think people will welcome it.
Giuseppe, thoughts? And
well, pretty much the same. I think it's about thinking that roles are evolving. I mean, what my job is today was not the job it was 10 years ago, but in medicine, we see that all the time. New tools, new technologies, new techniques are developed. And, even the way, just to say something, the way hernias are operated today is not the way that 50 years ago hernias were operated. And it's about that. And once again, I think it's about being open about the human in the equation. It's about making people get to use AI as a tool, not to think that they should be replaced by an AI.
Thank you. And looking at time, we're going to have to close that there. But it is an interesting response. Will people trust it? And I think we do have a lot to go, a long way to go in building trust that actually there is a feedback loop. Thank you so much, Timandra, and also Giuseppe, thank you so much for that. And if I could ask the first of our innovation pitches to come on, Aaron, if I could ask you please to come on, and I will hand over to you.
Perfect. Good morning, everyone. It's great to be able to share with you the role of machine learning in AstroSat's journey to create solutions to solve problems on Earth using space and ground data. We're an Earth observation company based out in Scotland. So our journey basically began in 2012, but in 2017, when the Scottish House Condition Survey was published, there was an estimate of under 25% of Scottish households who were living in fuel poverty. In England, that figure was 11%. To tackle this, energy suppliers were obviously asked to reinvest a percentage of their lifetime energy bill savings to make homes warmer. AstroSat, through the support of the European Space Agency and E.ON, developed a product called ThermCert, a fuel poverty prediction tool for Great Britain that is more accurate, and it's an alternative to the one that the government currently has. But it's accurate because it provides more up-to-date fuel poverty estimates at LSOA level. We used satellite data to measure residential heat loss and determine new built-up index. Together with this data, we fed it with other sources of ground data to create a fuel poverty prediction model, which is currently still being used. Our next example is basically when AstroSat jumped on the opportunity to try and help local authorities and third sector organizations identify people and communities who may be at risk of being vulnerable and isolated due to the stay-at-home mandate as a result of the coronavirus pandemic. Once again, we applied machine learning to predict employment vulnerability at greater granularity, this time at OA level. We combined this with other sources of data like access to transport, access to green spaces, and social isolation index to just help identify those communities so that they would not be left neglected during the pandemic. So where does that leave us right now? We're currently working with the Hampshire Hospitals NHS Foundation Trust to identify inequalities within communities to try and help them deliver the right services and care closer to home. We're using ML once again to predict different drivers of health inequalities with a view to pulling them together into a model that predicts health inequalities at community levels across the UK. I think my time's up. but I look forward to connecting and engaging with you further. Thank you.
Thank you, Aaron. That's fantastic. And yes, thank you. And if I could ask you to pop off. And next up, we have Design for Social Change with Priya Prakash, who's the founder of that. Could you come online and tell us about that, please, Priya? Thank you.
Absolutely. Thank you, Helen and Liz, for the invite. So we've heard today from both Timandra and Giuseppe about different models of AI. And I just want us to kind of reflect about how we ourselves use these services on an everyday level as consumers. So when was the last time any of us tried to find something decent to watch on Netflix or Amazon Prime and kind of gave up and then texted their mate and asked them for a recommendation? And your mate knows that you like probably musicals and gave you a great recommendation. It's one of your secret things. And then you actually ended up having a great time, something which Amazon or Netflix could not recommend very well for you. So this is what I find fascinating in terms of, we have one model of the child Terminator model that Timandra spoke about. We have Giuseppe's healthy skepticism, I totally agree, as a tool model. We have some great uses that Arun has spoken about. And us at Design for Social Change, we're excited by how we bring together the actual human intelligence, the intelligence of all of you sitting in this call, along with machine learning, the algorithms and the data in real time to solve the local problems that communities face, as well as the problems we are going to be increasingly facing with the climate emergency. So we worked with the Plymouth authorities and Amy Ferrovial. I'm just going to post a link which actually explains in detail about one of our last projects, which was working together with road users in the city of Plymouth in order to, in real time, find out issues, whether there were potholes to traffic, and find ways in which we could improve that, along with working with the service operators. It is Amy who had the contract with the city of Plymouth. What we've noticed is when you bring together human intelligence and use supervised learning, where you actually have humans like the people in the Amy Control Center to be able to tell us which are the issues that people have reported and which is the most important one to solve, versus a machine just predicting that without understanding what the local issues are, we have a better return on investment. So I urge you guys to have a look at the case study, and if you're interested to understand how you can work together with local communities, both offline and online, and have a platform that can integrate. Our platform is called Changeify. It's an application protocol interface that works by integrating in the middleware layer, which is the customer relationship management layer, where you interface with local communities. And we're able to create this real-time two-way feedback between the command control center operations that tends to happen within public authorities and the service operators and the citizens who are using your services. So that's basically from us, from Design for Social Change.
Thank you, Priya. Thank you. And if we could ask our final Jeff McGimpsey from Analytics Engine, if you could please come on screen.
Hi, everyone. I'm Jeff McGimpsey, and I'm the head of marketing at AI and data analytics firm, Analytics Engines. So I want to share a couple of ideas with you around machine learning and advanced analytics. And as Liz and the team at Civica has noted in the perspectives report, machine learning opens new possibilities to drive positive change. And we're really seeing that. And I want to sort of explore that a little bit further and look at data silos, complex legislation, predictive analytics, and picking the right tool for the job. So firstly, just whenever we speak to lots of public sector organizations, we're talking about their data challenges, and commonly we're hearing that they would like to break down the data silos and take control of their data. Now, knowledge graphs and techniques around NLP are being used to identify semantic meaning, named entities and contexts that can connect and bring together useful information across a range of sources. And this is really exciting stuff. But what does that mean in practical terms? So consider a really fundamental problem. How do you quickly read and understand a large corpus of complex and disparate legislative documents? So work is already underway to process the UK's statute book and other regulatory sources into a machine readable data set. So using technologies again, like knowledge graphs, users will be able to explore contextually relevant and related documents and receive a more holistic view of the legislative environment. And measures like this are going to be hugely transformative in terms of bringing government closer to the citizen, closer to the business user, to the regulator, and also to a range of other stakeholders. But if we move on to predictive analytics, for most of us, the real value in machine learning lies in the modeling for future demand and future events. In particular, we've been using machine learning to provide risk stratification tools to government auditors to help them understand patterns, anomalies, outliers within transactional data, and they can get a clear view of the risk events that may be contained within them. But for these powerful techniques to work appropriately, it requires a collection of really good quality historical data sets. I know we're doing a lot of work at the moment in terms of extracting, cleansing, and loading data from sort of legacy software systems for precisely this purpose. So again, just something for a takeaway for folks on the quality of the data that you're bringing forward for the modeling. But I would also like to wrap up with a caveat too, that whilst machine learning and other tools are great, they're not always going to be the right fit. Sometimes traditional data analytics and sophisticated rules-based algorithms are just the best tools for the job. So look, be creative, be open-minded. Remember that sometimes the simplest solution can be the best, but look, thinking ahead, and if you want to take that level up to embrace that new technology, where if you look ahead to the future, you can expect to see major reductions in training of deep learning. So it means that large complex modeling is in scope, it's more accessible, and the potential offered by machine learning, which is really well expressed within the Perspectives report, it's just going to be much more realizable for you, me, and the organizations that are in the room at the moment. So those are some of my thoughts around how we attack this area. I'm very pleased to pick up with anybody afterwards. So I hope it's been useful, and thank you very much for your time.
Thank you, Jeff. And absolutely, as I believe Kieran's just put into the chat, the links, etc., will all be shared later after the event, along with the slides, and there'll be a recap recording as well. So we will make sure that you get all the information. I would like to now move on to our panel session. Delighted to say actually that we've got a fantastic panel here. We've got Harold Denise, who's the Director of Cloud and Innovation at Civica, Eamon O'Neill, who's the Director of ART AI at the University of Bath, Dan Sandhu, the Chief Executive Officer at Sparks Learning, and Patrick Dawson, who's the CIO at Paradigm Housing. So a really nice mix there of views. But while that's coming on, I'm going to launch another poll, which is around, as Timandra said earlier, fairness and bias both have AI in them. So where is another multiple choice? Where is the most bias likely to enter the system? You can use two choices, please. Which are the two most important biases that you think that will it come in the data used to train, the data collected at the time, developing the people developing the algorithms, or actually is it the people in choosing the outcome that's there? I'm going to leave that poll up there running. And I think this idea of trust is something that it's been a running thing there. Can we trust AI? What is really, is that something? Will professionals trust those answers, the diagnosis, etc., that they're provided with? Eamon, would you like to pick up on that one first?
Yeah, I think some of the comments that have already been made on trust are absolutely correct. Trust is not something that appears overnight. It's built up over time. It's built up over many instances. It's all based on human trust. That's where it comes from. We trust or do not trust each other, and when we trust each other, that doesn't happen overnight, but it can be destroyed overnight. So evidence gets gathered. You trust someone more and more. Some counter evidence is presented to you, you may no longer trust them. And it's going to be quite similar with AI, along with some added complications, of course, because the AI isn't a human. Giuseppe's example there of the CT scan, for example, I was talking to a senior consultant in the NHS recently who is becoming worried, and says his colleagues are becoming worried that they're going to be in a situation where perhaps they can't win. So they'll either be told, you followed the AI when you were making your diagnosis, and you shouldn't have trusted it. Or they'll be told, you didn't follow the AI when you made your diagnosis, and you should have trusted it. So whichever they do, it's the human that's going to be held accountable. And in some respects, that's based on whether or not they chose to trust the AI that was supposed to be informing their decision making.
That's a whole new thing to think about for the doctor or the professional. I mean, Patrick, in housing on the front line, will people be, if they trust the allocation of housing to a vulnerable family because they trusted the AI or they questioned it, where does that responsibility lie?
It is a very interesting one. The use of the AI algorithm, I guess, is around the how we do something, but what are we actually trying to do? And in that particular example with allocations, obviously we're responding as a housing provider to the policy set primarily by local authorities. So we are given the rules to some extent to follow in terms of housing allocation. So going beyond those rules and using AI to allocate is quite difficult. Do you tell people that you're allocating using an algorithm, or do you follow the policies that are set? It's a very difficult one.
Actually, can we really strip that bias? Because actually, I'm just going to share the results from that quick poll. You know, a lot of people are saying that they're choosing the desired outcomes. Those policies can also be putting the bias in the system in the first instance. So, Dan, how do you think we can strip bias from it? Is there a way of doing that?
I think this is interesting, fascinating conversation so far. I mean, I'm in education. We're education technology, but we're with a big E. We're education technology, not education technology with a big T. The aim of technology and education should never be to overwhelm or undermine the teacher, always to support. And, you know, artificial intelligence, look into the eyes of a teacher when you use those words. You know, you're almost disenfranchising them from a profession they may well have been in 20, 30 years. The aim of AI in education has to be explainable. You have to make sure it's explainable. No black boxes. You can't have a black box where the teacher says, this is why the child was set this homework, or this is what the result is. Absolutely not. If the teacher cannot explain why a particular homework was set for a particular child, that is not useful technology. And that's really important because AI needs to be explainable and understandable. That drives what you were saying earlier about trust. So the concept of bias is an interesting one that, we've at Sparks, we spend years doing randomized, double-blind, randomized control trials in a double-blind basis to make sure it was medical standard research. And I think Damon said earlier, unless you have research and evidence, this is useless. Efficacy and evidence in education is everything. And we operate at Sparks at a medical standard. I mean, no one, even the Education Endowment Fund, does not undertake double-blind randomized control trials. We did that. Why? Because we never wanted our machine learning and our algorithms to overwhelm what we were doing in education. We don't even talk about it. How's that? We don't even go and put that on our presentations anywhere. Why? Because it's not relevant. The only analogy is, if anyone who's old enough like me remembers the photographs that you saw when you were kids of those sports cars in the 1920s and 30s with that big engine at the front and the drivers wrapped up in a little chair on the aim was to make a car for mobility, not to focus on the engine. You focus on the engine in the education, you forget the protagonist, that is the teacher. It's really important. So we always say, AI is going to be explainable to be trustworthy. It's going to be trustworthy, so it's used by confidence with the teachers. And if you make it explainable, the students learn. And so that's sort of where we are so passionate about making sure we have great technology, but never to disenfranchise the teacher. And if we ever feel that the teacher can't answer that simple question of why did I get this homework, or why is this being done, that just fails, doesn't work.
So the people always, it's superseded by the person, by the human being will always make the final decision and the final understanding.
We have a system in our platform that the teacher has the opportunity to make any change they want to the Sparks. I mean, but what happens? 95% of the time they don't, because they trust what comes out. That's the evidence of trust. And again, we talked about it earlier. What's the evidence of trust? When the teacher who has the option to change everything chooses not to, because they have confidence that what comes out is right.
But can it, in the concept of trusting AI generally, can there be a kind of like a spanner in the works there? In fact, Harold, this is one for you on the data front. Can we really strip that bias out? For example, Sajid Javid recently ordered a review of medical devices over racial bias concerns, and that's over a pulse ox monitor. So if we can't trust, if there's a bias already in the data that's coming in, how are we going to moderate that? How are we going to handle that? Harold?
Yeah, and that's a very important point, actually, because the reality is we always start with the data we have. I think a lot of us would like to say, oh, can we get the perfect data? But nobody can get the perfect data. You start with what you have. And I think the very important point here, there's two steps in machine learning. The first bit is the learning that creates a model, and the second bit is actually using that model. But in between those two, you need actually a specialist, an expert, to be able to say whether that model is actually useful. And I think that's the big problem with the black box, or the computer says no, for those who remember that joke, is that you need to have a human being, an expert that understands the field, that is able to kind of make that decision and look at the data, look at the model that's being created. Is this model helpful? Is this model biased? And not use the model until they feel comfortable that it isn't biased and that you're actually able to add value, and to the point that I think Dan was making, supporting the human beings who actually need to do the work.
Ayman, any thoughts on that from the data front?
Yeah, it's systemic. I mean, Sajid Javid's comments were actually really balanced and informed. He said there's a systemic problem here. It's not just about the device, and that relates to what Timandra said earlier too, that the devices are one part of it, the data itself is another part of it, but these devices and these data sets are being used by humans in a much broader system. And there is bias in many different kinds of ways in that broader system. And really, we can't effectively poke around with one aspect of it and hope to make significant changes.
So where would be a good starting point? Where do you start on that journey? I mean, it's a kind of like, you know, there's almost a self-defeating bit here, in that we're never going to have that perfect. Can we use data to train perfect data to find out where we've got the missing data that Timandra talked about?
Well, oversight is going to be important. And again, this is not something that's unique to AI. Again, yeah, would you trust a child to do certain tasks? No. So what do? Well, you oversee them. You look after them in a sense. You monitor it. You check that they've done the right thing. And the same is true for AI, certainly for the foreseeable future. I don't think there's any point in the next decade where we can trust AI to go off and make decisions by itself in any kind of truly unsupervised way. So oversight, I think, is where we start.
Yeah.
Patrick?
Yeah, I think it's an interesting question around our tolerance of bias and where bias comes from. We probably mostly start from the basis of we don't want any bias at all, but we have bias now. And the question is, how do we strip bias? But maybe we start with how do we reduce bias? And you know, with the goal of getting to zero bias, but we have bias built into the system already. And if AI can help us reduce that bias or identify that bias, that's a big step forward. As Ayman says, the oversight is key. If we allow the AI right now to run amok, we'll get into trouble. But I think our goal should be to reduce bias, or identify bias, reduce bias, and move forward. But I think the fundamental question is, are we more tolerant of bias coming from a non-AI solution than an AI solution?
That's a very interesting question. And that also comes down to, when you say we, as in the technology community, or we as in the public? And does the public have that? Are they data literate as a society? Do we understand that? I mean, actually, Dan, are we data literate within education? Do we start off with that knowledge to be able to make a judgment about, is there any bias in that AI?
That's really interesting. I think, you know, from our perspective, our aim is to make sure what we have as a platform using our AI works on the assumption, if teachers had access to all the data and all the time in the world, would they be able to set the best homework? Well, they don't have all the data, they don't have all the time, but we can set that homework on a bespoke basis for every single student. Why? Because, you know, we try to take that away, that bias away. We try to make sure they have knowledgeable information for every student. We look after 56% of all secondary school children in England doing mathematics. That means we have a lot of data. We have a real good understanding on how year 9 are doing this week in algebra. And that's got to be really good to allow that teacher to make sure they make a reasonable judgment on how Helen is going to do that work this week and what the progress is the week after. Does that take away bias? One hopes it does. One hopes it does, and it's an enabling tool. And, you know, education, thankfully, you know, has the aim is to make sure you continue that face-to-face experience as best as possible, but you give them more access to more data. You give them access to that functionality of being tech enabled, which they just don't have the time to set. I mean, can a teacher set homework for 25 kids independently every week, have it checked, have it assessed, and support every single student all the time? Logistically very possible, but logistically very difficult. And so how does one provide all the information to help remove the bias, help set that homework, and give them the tool? And most importantly, and I'm sure we'll talk about it later, it's adopted by the teacher. You can do all of that, and there's no adoption, so yeah.
There's an interesting comment in the chat from Eddie O'Neill actually saying humans fail too, which is very true, actually. We're assuming that humans make the right right decisions regardless, but humans fail too. He says clinical ethical concerns can be overcome. Simply blind the professional to the AI and use it to check for human error. That's an interesting thought. Harold, any thoughts on that?
Well, I think that, well, clearly humans are going to make errors and machines are going to make too, but you're more likely to listen to a human than you are to listen to a machine. At least most people are. And I think that's really the point here with machine learning is you need to be at the point where the decision is made by the human, helped by the machine learning, because that's when you go to a doctor, you expect the doctor to give you an advice. When you go to a teacher, you expect the teacher to give you an advice, not the machine that's behind it. However, the teacher can be helped by that machine. And I think that's exactly the kind of point that we need to get to, is where those teachers, those doctors believe in the data, or at least can see the value in making that. But at the end of the day, yes, you'd expect a human to make the decision. And yes, they might make a mistake like they do today.
I do worry though over Eamon's thoughts that who's responsible? Is it if that's the wrong decision, who is responsible? The AI or the human? Actually, there's an interesting, another comment from Eddie was that you need to have realistic goals for the public. Basic literacy would be welcome, let alone data literacy. Good point. Timandra has got basic, because ML tools have to be given explicit assumptions, it can be easier to see what they are than in humans. But of course, humans can be accountable morally in a way that machines cannot. Really good point. Eamon, would you like to pick up on that? Because I know that ethics is one of your big areas of academic research there. What is that moral imperative?
Yeah, well, error kind of leads into that, because with humans, we've had many thousands of years of figuring out ways to deal gracefully with error. And sometimes people just get stuff wrong and we forgive them, or we move on, or we fix it. But we also have things like negligence, where people get things wrong to an extent where we as a society decide, well, you got it so wrong there's actually a problem and we need to step in and do something about it. And that's where the accountability comes in, and in some respects the ethics. And that you cannot, as Timandra says in the chat, you cannot apply those kinds of processes and sanctions to AI. You can't accuse the AI of negligence in any meaningful way, and you can't sanction the AI in any meaningful way. So ultimately, it has to be some of the humans in that loop. And this comes back to identifying, well, which ones in which circumstances. You can't always easily trace the many people that will have been involved in the design, the creation, the deployment, the use of AI. I think in terms of both where we are as a society and where we are in terms of legislative frameworks and regulation, we are nowhere near up to where we need to be in accounting for all of this.
There is I mean, we had an AI conference last week, and we had Sana Karagana, the head of the Office of AI, talking about the fact that they are looking so hard into this, because it's a whole, it's greenfield. Where is the, where is the regulation, the AI, Dan?
Could I just, I'm sorry, when we started 3 years ago, we had 3 schools, and now we have 2,000 schools now. When we started, one of the first things I did, I put in place an ethics panel. And I put in place an external moderator. So Julian Hubbard, he was previously an MP, sat on the global, he led the ethics committee for Google DeepMind, and basically was involved in the Data Protection Act. And that we did without making a song and dance about it. We didn't do a rah-rah, we didn't put a PR release that we did it. It was just so I could sleep at night, to make sure that we had control over our ethics, over our data. After all, we're looking after a lot of students' data. And the AI platform, however good it is a machine, and it's, you know, human error will cause bugs. Things could go wrong. And so I felt it was my sort of responsibility, moral or otherwise, to make sure we had an external panel looking at our data and data ethics. So we have a panel of experts who started helping this, chaired by Julian, and that was really important. It's moving so fast. The world is moving so fast. There's so much data being gathered. You know, we 1.8 million children who do an hour of homework every week. That's a lot of data, and something can go wrong. So the only thing you can do is make sure, and with the right moral imperative, have that framework of ethics, put the process in, make it external to the organization, so you don't have that silly commercial dynamic involved in terms of whether you invest in it or not, and then live by the outcomes. And we have spent a lot of time really thinking about data ethics and how we push that forward. And then the ICO, the Information Commission's Office, have been really quite helpful and have been complimentary in terms of what we've done. But I think it's incumbent on everyone who controls that data within the AI platform otherwise to do that.
And interesting, just a quick aside from Eddie O'Neill on the Q&A, how did the credibility of the algorithms that you've got there, did that suffer, or did it enable the staff in there to do, you know, thinking about the pandemic, predicted A levels, etc.? Did they have the evidence there, or were they as stuck as everyone else? How did that go?
I think for us, it was, you know, we look at secondary school from sort of year 7 till GCSE. We didn't get involved. We don't get involved in the assessment of the exam side. All we could do is make sure we can demonstrate to the teachers how each student was progressing, and making sure we provide enough information to the teachers so they can make their judgment call on how to support those individuals, those classes. So at the beginning of every class, the teacher knew, in my class, 25 kids, they did homework last week. I know what the 5 key problems are, and I will help solve those. And that meant that we have not just engagement, not kids tapping on screens. When our platform is such that, amazingly, I know we're on an AI conference, but they have to write everything in a book with pen and paper. Amazing. But every student has to do book work. So what we drove was information, actionable insights. There is no point having something coming out. I think one of the speakers said earlier, actionable insights coming out every week for the teacher. And I think it was very supportive. Well, we know our completion rates are very high. We know we've got great feedback from schools and teachers, and we're always listening. But I understand what you're saying. It's very easy to get lost in it. It's very easy to let the AI black box run away, and then suddenly you get him into realms of smoke and mirrors, and you have education and ed tech professionals just claiming that AI will solve all the problems of no, it won't. It's a great enabler. It's a great enabler. But if we take it to another level, it is very dangerous not to provide the teachers the support they need.
Moving just over that on an enabler front, Patrick, you know, do we have that attitude within the public sector? Do we have the skills there to enable us to build those enabling tools, to use it? Do we have that in the public sector in specific? I mean, I know in some, you know, Google DeepMinds, we've got some very expensive, very well-funded people who've got fantastic, but do we across the wider public sector have that ability and those skills?
I think there's probably a bit of a gap between the people that've got the skills and the frontline business. And quite a few comments today have been around ensuring the outcomes that we're trying to achieve are right. So we have, as an example, we collect rent as a social housing business, and we look at people who are perhaps less likely to pay their rent in future. So we have some rent analytics going on, but that is based on currently on a sort of a handwritten algorithm. So that produces lists of people that we think are going to get into rent arrears, and we can intervene early on and signpost them towards benefits or other opportunities to avoid getting into that issue. We can improve that algorithm through machine learning, because we can say, well, we've got the inputs and we know who ended up in problems, so we can improve the algorithm. And to some extent, we're at risk of mystifying it if we say it's anything other than taking the existing algorithm and making it better. But I think there is a tendency for the AI and machine learning familiar people to make this sound so far detached from what we currently do that it causes its own problem. Because at the end of the day, what I'm trying to do is provide my people with better insight for them to go and take action on. We do that already. We're trying to improve the quality of what we do. So it's not a fundamental shift away, but if we wrap it up in sort of fancy language that they don't understand, that actually causes the barrier in the first place.
Harold, any thoughts on that, in what you're seeing across the front line? Are those skills there today? Is this something that we need to build on?
I think the skills are not that much in the public sector, and that's fair. And I think one of the things we talk about in our report is the fact that you don't always need to have the skills in the public sector. There's skills in academia, there's skills in the private sector. I think what is important is that combination of those technical skills, wherever they come from, and the business or the subject matter knowledge. And that combination of the two is the winning combination in our view. And the risk is that every council, every hospital in the UK decides, oh, I need skills there. I need to buy my own set of data scientists. Is that really needed? Will they be used in the right way? As opposed to be able to say, I know really what it is to be a doctor, to run a hospital, to run a council. Why don't I work with academia and the business world to actually get the data scientists that can do the things that need to be done?
So collaboration is the way forward.
Absolutely.
I've got a question in from Angus Wallace. Is we need to make healthcare more efficient. We can't deliver it satisfactorily at present with the workforce currently available. AI will improve the delivery of healthcare, and the threat to job losses is not important. Is it important? Is it? How are you finding that in general? Do people get worried about that? Eamon, I think this might be one for you to kick off, and then I'll come to Dan. Did teachers object to it? Eamon.
Yeah, so a couple of years ago, the Royal Society and the British Academy did an analysis of the impact of AI on work, and the conclusion that they came to, insofar as it came to any, because mostly they said, we don't know, but the conclusion that they did come to was that the impact is more likely to be on aspects of people's jobs rather than wiping out entire jobs. There will be jobs that disappear, as there is with every new wave of technology. New kinds of jobs will be created, and they're in that period of disruption. Some people will suffer from job loss and all the things that go with it. And eventually the dust will settle a bit. But for the most part, insofar as it's possible to predict, they were suggesting that people will continue to work, but aspects of their tasks will be automated and will be handed over to the AI rather than simply handing over their entire job.
So automation tasks, possibly of thinking later on. Dan, so how did teachers react to this?
I think it's a similar point there. It's about moving to a different level of engagement. If AI takes away a lot of the administration and aspects that the teacher is not really adding value to the learning experience, then it is powerful. If it provides them great differentiation around understanding individual students, not only in distributing the right homework in a differential way to individual students, but providing that information to the teachers so the teachers know how to support those students. That's a better use of the teacher's time than marking homework if it's already done in such a structured manner that they can add value. I think done right, it allows the teachers to be better teachers if they use it as an enabling tool. If you're positioning your AI and your AI is unable to provide that actionable insight, then rightly so. If I was a teacher, I'd be saying, I've been teaching for 10 years. I've been teaching maths for 10 years. What is this box going to tell me? If the teacher says, this information allows me to give a better insight on how I can support the students, and or it saves me a bunch of time so I don't take 30 books home every night to mark, that's going to be helpful. You've got to get that balance right. You don't want to disenfranchise the teachers, and it's not meant to be. Great scaffolding, great insights, and hopefully reduce the workload.
Yeah, I think. Sorry to Timandra framed the question really well there. He said it's not about how to do the same thing or more with less. It's about how to do more with more, if I paraphrase what she said. And I think that's really the power here that we can bring machine learning. It's not to try and replace people, it's to try and enable people to do things that have more value, to what the point that Dan just made.
Patrick, and how has that been on the front line? Because obviously every wave of technology, as Eamon says, does bring change culturally. How good are we in the public sector at accepting that change?
I can't talk about the wider public sector, but in my own area, I think we've been talking about the dawn of the robots for 50 years, 60 years, and it hasn't really got yet. And it was interesting, the Alan Turing sort of story earlier from Timandra. I think it isn't going to. People don't see it as going to take their jobs away. I think that they see it. They see it in their daily lives. We forget that sort of our staff members are also members of society who are consuming services like the Netflix example that came up earlier. And they're kind of expecting it, actually. And they're kind of surprised if we don't have it. So I don't think there's a huge amount of resistance on the basis that it is what Dan was saying. This is augmenting what's there. It's not replacing them. So in our world, what do most of our people do? The way that the paradigm works, we have 150 people that go and replace roof tiles or shattered windows or cyclically replace kitchens, that sort of thing. Now we're a while away from the robots doing that. Maybe that will come, but we're not really talking about that. But we are talking about, well, can we predict which roof will fail earlier so we can fix it before it's broken, which is a win for us because it's cheaper and easier to fix, and it's a win for the customer because they didn't have to have the leaky roof to report that we then go and fix. So I think everyone's looking at it quite positively. I don't think it's going to sweep away vast amounts of jobs. I think if you are in a more administrative processing support role, that is going to be more difficult going forward. But I think for the core roles, it won't have. It will augment and improve.
Question is, of course, though, where do we apply it? I mean, there are so many potential opportunities. There is so much data. There is so much that could be done. So where do we decide where to get the best value from machine learning? Where do we focus? Harold, let's pick up on that one first.
Yeah, it's a very difficult one because there's so many, to your point, so many opportunities to do things differently. I think the way I always look at those kind of things is it's start where people have the appetite to actually do it, where people have the data to actually do it. And sometimes you might have the perfect thing to solve with the perfect data to solve it, but unless the people are there to work with you on it, it's not going to work. But I think things that can help society, one of the things we're working on is to look at early signs of homelessness. I mean, that is something where if we can use the data in the right way and avoid even one person in the country to go homeless, I think that's huge, and their families. Another thing that I've seen and that I find absolutely amazing is, how they can predict which kind of treatment you need for a certain disease based on who you are as an individual, and not just say like, well, this disease means this kind of drugs and that's it. And I think especially now with what we're seeing with COVID and the new Omicron, there's definitely opportunities to do that could hopefully save lives.
It's an interesting one because there's a question in from in the Q&A. So if you have data on local population, is it possible for AI to predict health indicators and outcomes may help in better targeting health resources to people needing appropriate care? And thinking here that actually the public sector is pretty much bankrupt, but there is less and less money coming into public sector budgets. This is a reality that we all share. Can we use AI to find ways, should we be focused on where we can find ways to make savings, to improve outcomes? Eamon, where would you put that balance?
Yeah, that should be possible. The AI should be able not just to create the kinds of opportunities for interventions that Patrick talked about, so getting in earlier and doing repair and saving some money that way, but also identifying entirely new instances or areas where we can do things better that the humans simply can't spot. And that's, again, where do you deploy the human? In the stuff that the human's good at, and where do you deploy the AI? In the stuff that the AI is good at. And the AI fundamentally is looking for patterns and identifying features in those very large data sets that humans simply cannot do. Once you go to quite high dimension data sets, humans literally find it impossible to deal with them. And we talked about the public literacy. It's not just the public, even the experts cannot cope. No human can cope with a very large high dimensional data set and make any kind of sense of it. So the AI can, and that's where they should be deployed at the things they're good at.
How does that translate onto the front line, Patrick? Are you finding that, the push comes from, say, the tech team or the team looking at the data, or is it coming from, say, the business need and then someone going, oh, we could look at something through AI, machine learning on that front? Is it business-led?
I'd like it to be. I'm very passionate about this. I think to a large extent, I don't know, 80%, we ought to be saying, well, what are we here as a business to do? What services do we provide? How do we improve those services? How can we sort of delight our customers? And 20% ought to be the sort of data mining. I think there's a space for people to sort of fish around in the data and see what insight they can find and be data-led. But I think it should be much more business-led. So in our world, customer satisfaction, business efficiency, regulatory compliance, risk. I think we should really be clear on that and seek ways to achieve those. And actually in the report, I was looking at the things to do, the action list, and number one was understand your data. I probably slightly respectfully disagree that number one is understand what you're trying to achieve. That's really where we should start. That's where I think we should be. Where are we? No, I think we're not there at all. I think we're much more in the sort of needing to push this from a data perspective and show the actionable insights, or I like the term actionable, but I prefer the term actioned. So actually do something with the insights. And the more we see examples of that, so it feeds back and the business takes it on board and sees the benefit, the more appetite there is to do more of it. But it is, we're in the slow cycle at the moment, and I'd like to see us speed that up.
Dan, any thoughts on that one?
I've got to concur. I think for us, it's not developing more AI tools and machine learning tools for the sake of it, only if it makes a direct impact to the learning experience of students or teachers. We won't develop anything, we just don't do anything unless it makes a positive impact. And where it does, we will scale it and make sure we get better insights, better information. And as you rightly said, there's a lot of data coming in all the time and billions of data points. And if we can use our predictions in more complex models to give a better experience for the learner, provide more information to the teacher, that's fine. And we'll continue to look at those areas, but always by keeping the teacher and the learner at the center of what we do. We won't do it just for the sake of doing it so it looks pretty on a presentation.
Harold, do you agree with the understanding your data, what you're trying to achieve? Which one comes first, or are they the same thing?
So to me, it always starts with the data in the point of machine learning, right? Because the machine cannot learn if there isn't data. It's as simple as that. I think what you're trying to solve as a problem, you can have data, you cannot have data, and you can try and solve the problem. But if you want to use machine learning to solve a problem, the machine cannot learn without the data. It's very, very simple. But yes, it's really important for people to remember that, because sometimes you're like, let's use machine learning for this. Do you have the data or you don't? But that doesn't mean you can't start with the data that you have, but you can only learn if you have data.
I'm afraid we're nearly out of time. We've literally got 1 minute to go. So actually, if I could just ask everybody to come back on camera and say thank you to you all for a fantastic set of presentations, discussions, and inspirations with the innovation. Thank you ever so much to everybody. And thank you also for everyone for joining us today. We will be providing all the links that we mentioned today, and we'll be providing slides and all of the video recaps, etc. We'll all be coming out to you. I think the first thing you'll get, though, will be a survey asking you how well you thought we did today. Thank you for joining us. And now is the time to say goodbye. Thank you.